In today's tutorial, we will discuss how to skin geometry to a single bone. And we will look some more into orienting joints. Let's start with skinning. Let's create a simple sphere by clicking here. Then let's make a bone. Click on empty space in the viewport to deselect, then type in joint, down here. We can see our bone in the outliner window. And we can turn on X-ray joints mode. When you move the bone, you will see that geometry is not following it. So to skin it, first select the joint. Then select the sphere, and then go to Skin, Bind Skin option box. In skinning options, just reset the settings. Then specify selected joints here. That's basically all you have to change at the moment. Then press Bind Skin. Now the sphere is skinned to the joint and it follows it. So if you select the sphere, you will see that it has the skin cluster node here, under Inputs. Notice that if I move the joint, the sphere vertices will follow it. But the transform in here is not really moving. The transform is still here and it's locked in this position. It's just the vertices that are moving. If you select your sphere and go to Skin, go back to Bind Pose. It will all come back to the original position. Now, if you want to unskin your sphere, select it first. Then go to Skin, Unbind Skin. Now you see that you can move your sphere freely. And it doesn't have a skin cluster under Inputs anymore. Hence, when you move the joint, our sphere does not follow it anymore. Now let's discuss how to move skin geometry using a control. Animators like to use those instead of joints. Let's make a simple control. Go to Create, Circle. We can scale our circle. But let's do it only in component mode. Press F8, then grab control vertices with right click. Scale them to adjust the size. Once done, press F8 again to exit component mode. This is very important. You never want to have any scales on your controls here. Name this, Sphere Control. Name this, Sphere Joint. And this will be named, Sphere Geo. Now let's skin this Sphere Geo to the joint. And here let's make sure we are not working in the shape mode. That could cause a lot of problems. Okay. Now we have a couple of options to set it up. To make the joint follow your control. Firstly, you could parent the joint under your control by dragging it inside of it. But that's not the best option. Because your joints will sit in your controls. And then your skeleton hierarchy will be broken. So select the joint and press Shift P, to unparent it. Another option is to select your sphere control then the joint. Then go here to Constraint, Parent Constraint. Make sure to reset the constraint options. We want Maintain Offset to be on. Next click, Add. Now when you move your control, it moves the sphere. If you rotate it, it rotates the sphere. Unfortunately, the scaling does not work with this solution. If you want it to scale, you should select the control. Then the joint and go to Constraint, Scale. Again. Make sure Offset is on. Now you can scale the joint with your control and thus the sphere. Whenever you make a control, it's nice to have an offset group on it. To do that, go to Create, Empty Group. Then you name that group the same as the control, but with the suffix grp. Then you want to make sure that your control and the group have the same transformations. To match transformations, parent the group to the control. Then 0 the group transforms. Everything must be set to 0 but scales need to equal 1. Then unparent the group from the control with Shift P. Now parent your control to the group. Now you have a nice working offset group and the control is zeroed. You can rotate, scale and move and everything works perfectly. Now let's have a little talk about inheriting transforms and double transformations. So if you decide to put your skin geometry in your control, as you move it, not only the geometry transform will move, but also the shape with its vertices. This is a common problem in the rigs and it's called double transformation. To fix it, just make sure that your geometry is only moved by one thing. Whether it's a constraint, skinning or parent relationship. Same thing will happen if you group your geometry, and then constrain that group to the control. The best way to fix this problem is, go in here, select the geometry transform. Then in attribute editor set inherits transform to off. But this will only work nice if your geo is clean and frozen, and has no values here. Same goes for its parents. But best thing is for sure to use just one method, which will move your vertices on your geo, like skinning. To clean up you can just group your joint and name the group. Joints_GRP is a good name. Always try to keep everything nice and organized in your outliner. So often in games today, the artist will use bones. They will move every geometry asset, even simple props with just one joint, like we did here. Now let's talk about orienting our joints. For this we can use Comet tool we installed in the first tutorial. Go watch it and grab it if you haven't yet. We can make a new joint and duplicate it a bunch of times. We can parent the joints to each other to create a nice hierarchy. We can also flatten them by grouping them, then scaling that group to 0 in y-axis. Then we freeze scale on this group with right-click. We unparent joints. We delete the group. Now we can select the joints and see their orientations. To do it, use display, transform, display local rotation axis. As you can see, the orientations are all over the place. We want to make sure that every little X is pointing towards the next joint. To do that, we can use my Joint Orient tool, like in the last tutorial. But now that we have Comet tool installed, it will be easier. They are very similar. The Comet one has show and hide axis instead of toggle. Toggle can cause issues. You might run into problems like this. It will happen with toggle, especially in complicated big rigs, with a lot of joints. Another advantage of Comet tool is this tweak option, which is really powerful. The aim is the axis in which your joint aims towards the next joint, usually X. Up is the vertical up direction from your object, usually Y. Last one is the scene vertical up axis, usually also Y. So usually you end up with X, Y, Y. Then you can just orient joints with this setting. Make sure to press it twice. Sometimes it glitches. This tool also cleans up the rotations. It makes sure the last joint is orientated same as its parent. So it's very nice. And if you need to tweak something along one axis, or if you want to tweak all joints at once, just select them and use tweak. See how it rotates all the joints easily around X? And if you just want to tweak one, select it and do it like this. Very easy and nice. So that's X, Y, Y. It's the most commonly used orientation in games using Unity. And yet, as we said before, joint orients are simply a rotation offset group. So now you are almost ready to orient another more complicated rig. Let's just check out a few more little tricks. If you want to reset the orientation of the joint in a chain, unparent it, unparent its children. Now you can zero out its rotation and joint orients, like this. Now you can read parent it all back. The orientation problems, like in life, start when you have multiple children. The tool does not know how to orient this joint. And first of all, the tool fails because we have duplicate names. We need to rename one of the joints, thus making sure the names are unique. So if you orient the joints, you will see it's now aiming at its first child, joint 5. If you wanted to aim at the top joint, just flip them around in the hierarchy, use middle drag. If you wanted to aim forward, you can just tweak it in Y-axis like this. But there are better ways. You can just unparent the children. And now this will get orientated like its parent. Now parent the children back. Another way is to create the temporary aim target joint. So now if you just put it here, grab this and press orient. It will aim at the temporary aimer, because it's the first child. So whichever is the first child joint, the selected one is going to aim at it. Remember to delete your temporary aiming joint. Now the orienting is finished. So now you are ready for the next part. We will build an actual skeleton from scratch and orient it correctly. Thanks for watching. For more information send email to cornica3d@gmail.com. Make sure to visit our website at cornica3d.click. We have Unreal characters, Unity characters, useful tools, and CG tutorials.